Actually, you already know all this already. Just apply in the tutorial question only. Okay. Okay, so just repeat before we stop. So we have these three equations that you see on the screen here. So if the question asks you for of impulse and momentum, so you need to use the yellow color equation, which is mv plus integration ft equal to mv, break into x and y. And then you have another equation, which is I omega plus mg dt plus ig omega 2. So basically, you need these three equations to solve planar kinematics of rigid body. Okay, now if you look at the diagram, the object rotates and you have a fixed point there, A. Radius is given, moment is given. So when moment is given, you know that you need to use all three equations that you've seen in the screen just now. Force is given. Okay, so 10 kilogram of this mass is given. Act upon a constant couple moment 6 Newton meter and a force 10 Newton, which apply to a chord right around its surface. Determine angular velocity with its omega. Of this 2 seconds after starting from rest means you're given the time, means you integrate 0 to 2. Okay, means in this equation, this T1 equals 0, T2 equal to 2. You substitute, then you do integration. Because this equation, sometimes your force is not constant, your force have a value there in the time presentation. So in this case, it's a constant. Yeah. So you need to find 2 seconds, what happened from rest. From rest means it will cancel some of the parameter in your equation, which is V equals 0. V1 0, omega 1 0. You need to write V1 0, omega 1 0 also got marks one. 1 mark, got 2 mark here. And then don't assume I know. You need to write. So also, what is the force component reaction at the pin? So the pin there always have x, fy and fx, or ax, ay under that. So you draw free body diagram. So you are focusing on the disc. So you draw free round body, and then point A. Okay, y go up positive, go to the right positive, x and y. And in this case, we are following the motion, although we are using right hand rules. But to keep everything in positive, we will change our positive direction clockwise positive. Yeah. So for dynamic question, always look at the motion. You follow the motion direction. Then you will arrive, all your calculation will be positive. Okay. Yeah. Of course, you can still stick to right hand rules, but you will get negative value. Okay. So you put in the A point, and then you put in the 2 force there, AX, AY, and the A there. And then what do you feel as the ring there or the disc there? So you have a force there. And what else? You have a moment there. W. This will be the component they always forget when they go to chapter 6, 7. Okay. W go down from the center. AX, AY. And there's a moment. Okay, so should be no issue. This diagram. So what is a careless mistakes? Your W always missing. In the chapter 7 or chapter 8. So yeah. So if you refer to the appendix, your IG will be half mr square because it's a circular disc. Yeah, this formula is from the appendix. Okay. So you put in the parameter, your IG will be, IG for this A will be half 10 kilo multiplied 0.2 square. You get one value, 0.2 kilogram meter square. Again, in your test or final exam, unit is important. Don't just give me value. You put in the unit there. Huh? Okay, so we solve for the I first. Meaning for your test two, don't know, if you don't know how to do, just calculate the I first. Calculate I, then you will see how to do already. Then use these three formula. Principle of impulse and momentum. Pull these three equation, put inside the your answer sheet there. mv equal to ft equal to mv2, and break into x and y. X move to the right positive, y move up positive, and angular velocity I omega plus mt equal to I omega 2, and you fix that you follow the motion of the body clockwise positive. Then you fill in the blank by using this skeleton or using these three general equations. Okay. So for the first one, because you start from rest, your MA1x0. Force is given. Force force will be AX here. You're looking at X direction. You're referring to this diagram and not that diagram. This diagram in X direction, you only have X. Don't include other. Other is a wider component. AX multiply 2 seconds. Or you can do the integration if you want. All right, you still arrive at 2 seconds. And M is given. V2 you don't know. V2 is why okay. V2 why V2 is 0? Why V2 is 0? Yeah. The these are always at that position. The velocity do not go anywhere. The gravity center of mass do not go anywhere. It do not roll on the ground. If roll on the ground, then yes, there's a V2 there. But this one pin there, so it just rotate. So V2 0. This is a common sense. This one common sense. You should able to explain to your juniors when the junior asks you why V2 is 0. Because do not roll, it do not roll and change position. Okay. So you should able to do the second one, y direction. So the first one will be MBA1, it will be 0 also. So you only have all the force in y. So AY go up positive 2 seconds. W go down negative 2 seconds. And you have 50 Newton pull down minus 52 seconds. So what about MBA2? Why? 0 also because the thing do not fly up. It was pinned to fixed location. Then you fill in the blank here. I you already calculate just now. I you already calculate. Omega you don't know. You need to find. Okay. Omega 1 is 0 because start from rest. It do not rotate from the beginning. Then MA dt, M is given 6. T is 2 seconds. And there is a 50 Newton also. 50 Newton. Yeah, correct. 50 Newton. And then I is 0.2. Just now you calculate 0.2. Just now this one. This one. Just now you calculate this one, 0.2. So you substitute 0.2 omega square. So you're having 3 equations. You can solve how many unknown? AX, AY, W, you know, mg. Then here you only have omega 2. So you have 3 equations. You can solve 3 unknown. Which one? This one. Your pull here. This rope, 50. This one, is it? This one is your given here. This one M. M is 50. Yeah, M is 50. Sorry. This one, is it? This one. Okay. Yeah.
Then M8
Yeah.
Các bạn làm cái external bắt đầu external the moment it's the
I think something. It should be something missing here. It should be this one. It should be multiply 0.2 here. This one missing. This 50 forces convert to moment. F multiply 0.2 get moment. So I think there's a typo error lah in my slides. I think. Wait, I think there are some typo error on my slides. So this one, the below this one, I think got typo error. This one. Yeah, this one is less 0.2 lah. It should have 0.2 here. Okay, you calculate. Sometimes got some error in my slides. Okay, you see the same approach also. This one also same, but there's a force at here. It's a bit different from the previous one. Previous one, there's no velocity given, but you're given the moment. But here you're given the velocity here. Okay, so if you have velocity here, you can find omega, right? How? V equal to what? R. Omega R. You can convert this one into omega. Once you have the omega, you apply to this body, omega any point, same. Okay, so I just go back. You draw free body diagram. You have the tension cable down, W go down, and because it's a pin, so you have AX, AY also. And you want to find the T will equal to WB. Yeah. This diagram is just to verify your value of your T, the red arrow T. Okay. So again, pull out the three equation. Pull out the three equation. Then you start solving. So here you have two objects and a cylinder. So okay, so this one do not start with 0. You are moving down 2 meters per second. So what you do, you break the object into two objects. Then you transfer some of the parameter back to another object. Because it's linked, two object is linked. So you pull out the two equation, you use angular momentum and also linear momentum. So here's I omega 1 plus m dt and I omega squared. So I you can find, I assume you know how to find A. This one refer to the appendix and it's half mr squared, if not mistaken. You find this one. Omega, you don't know, you just put as unknown. Then you find the moment on the disk. Moment, how to find? Force multiply perpendicular distance. So t multiplied by 0.2. So just now on my slides, example 2, there's a missing radius there in my answer. Okay, so I, you know, is 0.4 and omega 2, you don't know, just leave it there. Then you can go to cylinder to find. You put in M, you know, VB, you know. This one is go up positive, so your V is negative. The first term is negative. Second one, F dt, F is positive because the tension is go up. Tension go up, 3 seconds. Okay, and this one, W, mg, 3 seconds also, go down, negative, equal to minus mb. Why the negative? Because velocity is go down. You know that no matter how you let go, it will still go down because of gravity. So you know that your VB is negative, it will go down and not fly up. Unless you let go of a helium balloon, then yes, positive. Because mb, mg, weight Wmg. Wait,
And get the math of hot dog. 6 kg and 50 kg in Japan. Into 6 20.
6 multiply, wait,
Ignore the rock. Ignore the corner.
it should be some decimal point lah. So if you take 6 multiply 9.81 is what? Is 5 point something, right? So decimal point missing in my answer here. Okay, there's a dot missing here. Yeah. So I'm not sure this one in the assignment. Oh, this one. Okay. Now some of my assignment, I will catch all these mistakes. You just copy blindly, then you won't get full marks. Okay. So once you have this equation, then you can convert what you know from the V, omega equal to V equal to omega R. So you can convert V divided by R. R is 0.2. V is the tangent direction, and it must be perpendicular. The V and the R must be perpendicular. Right? So once you have omega, you can substitute in. Okay, so omega 1 is equal to 10, substitute here. Omega 2, you don't know V2, but you know the R. So you just leave the V2 as parameter. So you have 5 V2, so substitute here. Sorry, here. Where? Here. Yeah. Because your V equal to omega R. Yeah. So you solve, then you get VB equal to this value. VB2 in here, this equation. Once you solve this one, you arrive at VB2 in this equation, the purple color, the first line here. You substitute inside here, or you solve simultaneous. You either you multiply, then you minus, or you multiply or you add, depend. Then you arrive at only one parameter, which is VB2 equal to 13 meter per second. Go down. You get positive value. It means so you'll get negative value. It go down. Because here your direction go up positive in your solution. You assume go up positive. you will get negative value of your VB. Then don't stop there. You need to tell me the direction for your test 2 and final exam. You need to tell me what is the end result. What is the motion behind the value you calculate. Okay, so I'll show you the solution 1. Solution 2 is your homework. The homework is using another formula with its angular momentum. This one is using diagram to solve. This one direct use I omega m dt to find the missing VB. Okay, the last part of the chapter is on the conservation. Conservation, we do not consider the impulse in the middle, so we only look at momentum. So means mv1 will equal to mv2, and angular momentum will same to the angular at the back. So it's the same. So the first one, linear 1 equal to linear 2, angular momentum equal to angular momentum 2. What does it mean? If you refer to these two equations, refer to these three equations, the integrate part is 0. So mv equal to mv2, I omega 1 equal to I omega 2. You need this conservation for your test 2. Last question. Okay. So now what does it mean is that if you use conservation of angular momentum or angular linear momentum, again, the question asks you, what if you increase the mass of that object? What will it affect? Or what will it affect the motion of that body? So you need to use this to explain. Okay, so if you have something, a wheel that is moving towards the A point there, so it will go up and then down. Okay, the distance, the gap of A to the fixed surface or flat surface is 0.3 meter. Mass of the wheel is given. You are given moment of inertia, Ig is given. So you don't need to calculate, straight away give you the Ig. Assuming the wheel do not slip or rebound. So do not slip means there is a friction or a contact force there already. Of course, in this here, it do not give you the friction. You can put in the friction force in your equation. So determine minimum velocity must have to roll over the construction at A. So we use impulse momentum diagram. We use impulse momentum diagram, which is a tree diagram. The first one, you calculate G and the datum point. We use point A datum as your reference point. So you look at the center of your mass, and the first diagram in the impulse and momentum diagram is all the linear velocity with at the center of the mass, and then it will roll to the right. So you put in mv1 pointing to the right from the center of mass. What happened to Putra? Don't know. Okay. And then you have omega 1, you start to rotate. So you have Ig omega 1. So this is the first diagram for before impact. So you have V and omega 1 plus M, you have to write MV and I omega 1. This is before impact. Your diagram look like this. Okay. During impact, During impact, there is a contact force there. There's a contact force at perpendicular distance of that contact point. So you have the F dt there, and omega W point down. This is before touch the point A. This is before, and then during the impact, it will touch the point A. Yeah. So first diagram is more on the velocity and angular velocity. Second one is on the impulse, all the forces that acting on the object. So you have weight and the external force. Equal after it roll over the A. What you have? You have the omega 2 and also velocity. So V will expect to go somewhere up because it's rush up like that. This is just your estimation. You can calculate later from the first two diagram later, split into X and Y, and then find resultant. But this is what we expect. And it will roll clockwise. Okay, so this is a complete diagram for this example 4. Yeah, so first diagram will be V and omega. Second diagram will be all the force. Third diagram will be only velocity and omega. Yeah, it's a come by set one, by this set, mv, I, omega, wt, ft, and mv and I omega 2. So when you read, so by comparison, force at A is much greater than the weight. Since time impact is very short, weight can be considered impulsive, non-impulsive. The impulsive force point A has both an unknown magnitude and known direction theta. Okay. So to eliminate the force from the analysis, our angular momentum at A is conserved. Yeah. Because your W dt here is very, very small. Consider conserved. Yeah, consider conserved. So you use conservation of angular momentum, H1 before equal to H2. So how to calculate angular momentum? You take mv multiplied by the perpendicular distance. So your mv, how to get this into moment? This one multiplied by the perpendicular distance. mv multiplied by this distance plus I omega already a moment. Okay, 2 is here. 2 is this one. And the perpendicular distance we don't know. Yeah. Perpendicular distance R we know, and R omega 2. And because no slipping, you can use V equal to omega R. So your omega equal to 5V. Substitute inside, and you solve. You put in all the parameter in the slides. You get V2 equal to 0.8921. Okay, so this one is your reading lah. Is your reading. Why we don't use conservation of energy? Because energy is lost during the climb up. Okay, so you cannot use that. Okay, this is another example lah. I will stop for maybe 1 or 2 minutes. You can copy lah if you want. Huh? Focusing on O. G also can. But for this impulse and momentum, we focus on center of mass. Okay. Yeah, we continue. So you have this case where you have a rod and a bullet shoot at a certain angle and hit the rod. So the rod will what? Will do what? Rod will swing left, right, or swing clockwise or anti-clockwise? Anti-clockwise, Okay. So you have a certain angle, and you know that the rod will swing anti-clockwise. You're given the velocity of the V, so you assume when you hit the rod will have a velocity at 400 also, and then change the V into rotation. Mass is given 4 gram. You need to calculate angular velocity, the omega of the rod just after the bullet become embedded to it. The word here embedded means your mass is go inside. So the rod is 5 kilogram. The bullet is 4 grams. So actually the mass of the bullet can be ignored. Or you can put in 5.004. But when you multiply, you won't see the effect. Very, very minor. Okay, so the impulse momentum diagram basically break into 3 diagrams. One is velocity. Center one is all the force. The last diagram will be the velocity. And if there is a rotation, then omega. So you have V1. You know that V1 don't have rotation. You can put in omega also, but omega 1 equals 0. You are focusing on the rod, right? So first diagram is V1 and omega. So MV and I omega 1. Second one is all the force, external force, all the resistance, all the pin, weight, and the weight of bullet also consider because embedded already. And the last diagram is I omega and the MV. So in this case, because we know that it's anti-clockwise, we assume all the anti-clockwise direction is positive. Then you pull out the three equation, solve using this diagram to solve. Yeah. So MV split into X and Y. You have Vx and MVy. Here also you have OX, OY, WY, W bullet Y, W rod Y, and W bullet Y. Here you have omega 2 anticlockwise, and also you have two forces there, rod mass and bullet rod. Okay. Although bullet rod is very, very small, but you need to calculate. Okay, during impact, the bullet and rod exerted equal but opposite internal impulse at A. The impulse that are external to the system are due to reaction at O and the weight of the bullet and rod. So since the time of impact is very short, this one is very, very short, delta t. So the moment of the weight impulse about O, it will be considered 0. Of course, the distance also 0 lah, because it do not move like that. Okay. So angular moment, this one consider conserve. This whole thing consider conserve because all thing here is 0. So when you conserve, you only calculate H1 equal to H2. With this, you take MV multiplied by the perpendicular distance of the momentum equal to the momentum after. Moment of momentum after. So here you are solving unknown there. Yeah, so you have before is this one, this diagram, first diagram. Middle one already conserved. And the last one, you just copy the MV for rod, MV for bullet, multiplied by the arm. For the rod is, for the bullet is 0.5 and 0.75. The and what and yeah, the rod is the total distance of the rod or total length of the rod is 1. So it at half of the this one, the G is at the center of the rod, so it's half 0.5 and I omega 2. So you solve, you will get this line 1 equal to something something something. Yeah, 1 equal to something something something. And because it's pinned to O, you can convert your V equal to omega R. You can convert your VB into omega term. Okay. You substitute there. So for your G2 is omega 0.5. V2 is omega 2.75. Substitute there, you only arrive at 1 the omega 2. It's a linear equation. So you solve omega 2 equal to 0.625. Okay, so with this, we conclude chapter.